So this is the video for section J, the second part of it, on standard deviation. So in the previous video, we talked about standard deviation of just sort of your basic groups of data. Now we're going to look specifically at grouped data. So data where you have a number of data points that are all the same, and so we group them together and we end up with a column of frequency. So starting with the equation, again, looks reminiscent of the basic standard deviation equation, but you'll notice that there's a couple of F's here. So everything is the same as the previous video. S is standard deviation, X is your data values, X bar is your mean, and F is now the frequency of the data values. So that now is going to play a part in determining the standard deviation. So let's go through a couple of examples. So first example, find the standard deviation of this distribution. So we've got a set of scores, maybe it was a test or something, whatever it was scored out of 4. And so one person had a score of 0, 2 people had a score of 1, 4 people had a score of 2, 2 people had a score of 3, and 1 person had a score of 4. So that gives us our frequency column, although it's not really a column. So we want to find the standard deviation of this. So here's our basic formula that we're going to need to fill in. We need to figure out the mean first, or first-ish. One of the first things we need to do is figure out the mean. So I've got mean set up and ready to go here. So when we're talking mean of group data, it's going to be the sum of the frequencies times the original data values, because there are, let's say there are 4 2s. So if we wanted to sort of add that together, we have to add 4 times 2, 1 times 0, 2 times 1. Instead of just going 0 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2, and so on. Okay, so to make things simpler, we have a chart again set up for us. So we've got our X, which is our data values, and we've got frequency already in. So the next column is F times X. So we're going to take each of those data points and multiply it by the frequency. So we end up here with 0, 2, 8, 6, and 4. So we had a total of 10 scores if we add up all of the frequencies, and if we multiply frequency times the original data values, we end up with 20. Okay, so over to mean. So X bar, so now it's the sum of all the F of X, sum of all F times X, so that's my 20, divided by how many scores I had altogether, which is the sum of all the frequencies. So my mean here is going to be 2. Okay. So now the next column is I take each of the original scores and I subtract the mean from it. Similar to what we did when we were just calculating our basic standard deviation. Okay. Next column, I'm going to take all of those differences and I'm going to square them. So again, this removes the negatives from my calculations, and the square rooting at the end will take care of the squaring. So then the next column here is a new column. So we're going to take all of these differences that we've squared, and we're going to multiply them by the frequencies. So we're multiplying all the differences, right? This X minus X bar squared. We're multiplying that by the frequency. So we're multiplying this column by this column. So we end up with 4, 2, 0, 2, 4. And then for the formula in the end, we need the sum of all of those calculations. So sum that all up and we end up with 12. So once we have that, then we can go ahead and get started on the formula. I say get started, but there's not really much to do. So on the top here, we've got the sum of what we just figured out. So that was the 12 that we just figured out over there. And the bottom is the sum of all the frequencies, which we had figured out over here. So the standard deviation of this is going to be the square root of 12 divided by 10. So square root here is approximately 1.10. Okay, so that's how you manage grouped data when you have a frequency in addition to the scores. Now, having done it this way, you could have done it the way we did it in the previous video and just eliminated this frequency and had 1 0 and 2 1s and 4 2s all listed out in your big long column. But when you start to have a lot of data points, if you can group them, it sort of simplifies the work a little bit. I know you might not be thinking it looks simpler, but if you had done it with all 10 of those values out in one long chart, the way we did it in the last video, that would be more work in the end, I promise you. So that's sort of your basic grouped data example. So now I want to get to an example with categories, with intervals. So the example that we're going to do here, estimate. Now this is an interesting word. All along we've been calculating, we've been finding. So now we're estimating, so that you need to be able to read math and think, that's different. So what does that mean? Well, we'll get to that. Estimate the standard deviation by using interval midpoints of the following weights. So now we have classes. We have interval classes of data. We don't have, as we did in the previous example, exact values. We have intervals. So we have one weight that falls in between 50 and less than 60. We have 3 weights that fall in between 60 and less than 70. So the reason why we're estimating is because we don't know exactly what those 3 weights are. We just know that they fall in this range. So that's why we end up estimating. And that's why we end up using interval midpoints. Because we don't know the exact values. We don't know what these 9 values are. We just know that they fall in between 70 and less than 80. They might all be 70. They might all be 79.9. We just don't know. And so on. So in order to do this, we're going to estimate the standard deviation by using the center of the class. So we're going to take these values, and since we don't know exactly what they are, we're going to arbitrarily say that all of them are exactly in the middle. Is that the case? Absolutely not. Well, it might be, we don't know. But probably not. They're not all going to perfectly average 55. But that's the number we're going to use in order to estimate the standard deviation here. So for this class, we're going to estimate 65, 75, 85, 95, and 105. So those numbers are now going to become our X. So now we're in a similar situation where we were in the previous example, where we have we have scores that are exact-ish that we're going to use. So we're going to use these numbers as our X's. So we can put in our frequencies here. We've got one of those, 3, 9, 6, 4, 2. Okay, so if we add up our frequencies, we're going to need that to find mean. We get 25, and now to do this FX column, we're multiplying frequency by our center of class, which is now our X value. So we're going to multiply 1 by 55, 3 by 65, and so on. Okay, so we've got all those multiplications done, and then we also want the sum of this, because we need the sum of f times x for our mean calculation. So if we add that all together, we get 2025. Okay, so let's take a break from the chart for a minute and work out our mean. So we've got x bar is equal to the sum of f times x, so the sum of this column, which is 2025, over the sum of x, so the sum of all the frequencies, which is 25. So our x bar, our mean, is 81. Okay, last step is standard deviation. So we need one more piece of the puzzle. We need this f times the subtraction here. So in the previous example, I had done out a separate column for each of these. So I'm just going to sort of simplify this process a little bit. So in order to find this, I'm taking x, which is 55. I'm subtracting the mean, which I figured out to be 81. So I'm doing 55 minus 81, squaring that, and then multiplying it by this frequency. So I'm doing x times x bar, square that, then multiply the frequency in order to find this column. Okay, so now that I've got all of those, in order to do the standard deviation equation, I need the sum of all of those values. So I'm going to add up this entire column, and that gives me 3,800. Okay, so now I can get to the formula. So sum of all of these frequencies multiplied by the data points minus the mean squared, that was all 3,800, divided by the sum of f. So the sum of all the frequencies added up was 25, or all of the weights. So we had 25 different weights. So then we're going to do that division, square root it, and we get approximately 12.3. So this is an estimation, remember, because this is not exact. We did the center of the class because we didn't know exactly where those weights fell in the intervals. So this is an estimation, more so than an exact standard deviation calculation. On something like this, on a question like this, you might be asked something like, can you find the range? The answer is no, we can't find the range because we don't know what the maximum value actually is. We know that it's somewhere in between 100 and less than 110, but that's about as specific as we can get. We also don't know the minimum. We know the minimum is somewhere between 50 and less than 60, but we don't know exactly what it is. So on a question like this, you couldn't find the range because we just don't know what the actual maximum and minimum values are. Okay, that about does it for standard deviation.